everything you need to know about conic sections, starting with parabolas. Parabolas are U-shaped graphs that can face any direction, up, down, left, or right. The way we know which way it faces has to do with what variable is squared, because the deal with parabolas is that only one of our variables, either x or y, is squared. So if we have a parabola that opens up or down, that means that our equation could be solved for y. Now, the way we normally write our equation, like this, means that it's not actually going to be solved for y. The idea is that if we wanted to, we could solve this for y and get it by itself easily. This parabola opens up or down, and the way that we decide if it opens up or down is based on this number outside of our parentheses. That number is either going to be positive or negative. Positive opens up, negative opens down. The other kind of parabola we can have that opens left or right is a parabola where we could solve for x. X is left and right, so we would solve it for x, which means that y is over on the left side squared, and x is on the right side, and if we wanted to solve for x, we could. This parabola opens left or right, and the way we decide, again, is based on the number that's outside of our parentheses. Negatives open left, because that's the negative direction for x. Positives open right. The other things we need to know about our parabola is the different parts. So for any given parabola that we've got, no matter which way it opens, so let's say we've got one up here, opens up, we have the vertex, h and k, which in this case is the bottommost point. We have the focus, which is on the inside of our parabola, and then we've got a line that's called the directrix that's on the outside of our parabola. The thing you have to remember is that P is how far it is from the vertex to the focus, or how far it is from the vertex to the directrix. Each of those is P. P being what's in our equation, or depending on what they give us, we should somehow be able to find P. Another part of our parabola is the focal width. So at my focus, this point inside my parabola, the focal width is how wide my parabola is at the focus, and that is 4p. So whatever number's in front of my parentheses, that's my focal width. Depending on what they give me is how I'm going to approach the problem. And so if, for instance, they give me, like on number 1 in the review, that my vertex is 0, 0, and my directrix is x equals -2. I may not have to graph this, but it is helpful to think about the graph. I have a point at 0, 0 that's going to be the max or min, and depends on what direction it's going, but that's going to be a really important point on my graph. The directrix is at x equals -2. So that's a vertical line through -2 on the x-axis. And so that tells us two things. It tells us what P is, because P is the distance from the vertex to the directrix, so P is 2. It also tells us that we're going to open to the right, because we open away from our directrix. And so that means that I can find a whole bunch of things now. I can find the equation, because since it's at 0, 0, I won't need parentheses, I'll just need y squared and x. I know it's an x equals because it is going to open to the right. And then because I know what P is, I put that in. This number in front of x is 4 times P, so that's 4 times 2, which is 8. So 8 goes in front of x. And then I do need to think, if it opens right, should this be a positive or a negative? Since it opens right, it's a positive. So my equation is y squared equals 8x. If I want the focus, then I have to think about, if I go the other direction, that same distance P, what point is that? And so that's why it's helpful to graph, because then it's really easy to see that the focus would be at 2, 0. The focal width is 4p, so we already figured out that that was 8. Because I know the focal width is 8 now, I can finish drawing this. If at the focus I have to be 8 wide, that means I would go 4 each direction. And so this is how wide my parabola is at my focus. And so I would just do my best to draw a nice U-shaped graph going through those points. And then we already said it opens right, which was the last part on number 1. So when the vertex is at 0, 0, a lot of times that makes things simpler to think about. So let's think about whenever our vertex is not at 0, 0. So on number 2, they tell us the focus is at -5, 3, and they tell us our vertex is at -5, 6. So again, you may be able to do this without graphing, but to me, as a mathematician, it just seems so much easier if we graph. Okay, so my vertex is at -5, 6, which is up here. My focus is at -5, 3, which is below that, right here. So right away, just from drawing those 2 points, we should know that it opens down, because we always open toward our focus. We can also figure out what P is. It doesn't ask us for that, but we need that information. P is how far away it is from the vertex to our focus. Well, if we've got it graphed and we've got grid lines, we just need to count. Or you can look at the 2 points and say, how far is it from -5, 3 to -5, 6? Either way, we should get that P is 3. Once we know that P is 3, everything else should follow pretty easily. For instance, it asks on this problem for the focus, but we already know the focus. So instead, let's say what the directrix is. The directrix would have to be 3 the other direction. So it's 3 up from our vertex, which is y equals 9, which is just barely off of your graph on the review. And then our focal width is 4p, and so that's 4 times 3, which is 12. So this is going to end up being kind of a wide parabola, and also one that goes off of our graph. And so you just have to do the best that you can to draw that. That's terrible. Don't judge me for my parabolas. So something like that. So all we have left now is to write our equation. Since it opens down, that means that y is not squared. So we're going to have x, we put in our vertex, so +5 equals our focal width. Now, because we're opening down, this would be -12, not +12, because our focal width is always the absolute value of what's happening in front of here. So in this case, we need to put that negative back in because we're opening down, which is a negative direction. And then y -6, because we have to put our vertex, -5, 6, goes here and here with the signs changed. So there we go. Now, the only other part of this that can be tricky involves us having to complete the square. So let's skip over to number 5, and we're asked, basically, I guess, to find the equation is what we want to do, and then so that means we're going to graph it as well. This is a particularly unpleasant problem as far as completing the square goes, because we're going to end up with some fractions. What we do when we complete the square is we look at where we have a squared variable, which I have a squared variable right here. Because I have a squared here and I also have another x, I have to complete the square on these 2 terms. To do that, I can't have a number in front of x squared, so I need to take out that 3, but I have to do it to both of these. So if I take the 3 out of 3x squared, I get x squared. If I take the 3 out of -6, that's -2x. Then I'm going to leave a blank. That's where I'm going to actually do my completing the square. These other 2 terms, I'm going to move to the other side, because if you think about the way we want this to end up, we want to end up with x in parentheses with a squared, some number, and then y in parentheses without a squared. So that's why this is on the left side, because we've got a squared. We're going to move these other 2 things over to the right. Now, when we complete the square, we take the number in front of x, we half it, and we square it. And so negative 2 divided by 2 is negative 1. When we square it, we put it in parentheses, so that's a positive 1. I put a plus 1 here, but I have to keep my equation balanced. And so what I really did when I added 1 is I really actually added 3 times 1, which is 3. And this is where my problem happens. I'm going to add 3 to the other side to keep my equation balanced. The 3 that's on the outside is just going to hang out while we factor the inside. We say what multiplies to get 1 that adds to get negative 2, which is negative 1 and negative 1. Since those are the same number, that's what allows us to put our squared on the outside. This equals 6y minus 7. Now, in the next few steps, the order we do this in, you don't have to do it in the exact same order as what I do it. We, at some point, need to divide by 3, and we also need to factor the right side because we want to end up with just one y and then some number with a number on the outside. So it doesn't matter if you factor first or divide by 3 first. Let's divide by 3 on both sides so that we get x minus 1 squared equals 2y minus 7/3. Now we're almost there. The left side doesn't need to change because it's what we want to have happen here. The right side, we need to take out a 2, and this is where it's especially weird. If I take a 2 out of 7/3, what does that mean I'm doing? It means I'm dividing by 2, and so that's going to give me 7/6. And what matters is if you distribute the 2, can you see that that equals 7/3? Well, if I distribute the 2 and the 6 cancel and gives me 3 on bottom. So depending on what the question actually asked us, which this question isn't super clear, this is the equation. We have a graph over on this side, and we need to graph the vertex at least, which is 1, 7/6. So that's almost 1, 1. We know that it opens up because y is not squared and because 2 is positive. And then if we wanted to, we could find the focus and the focal width and all that. Or we could just be like, bam, there's our parabola, since it didn't actually ask us to find the focal width and all that stuff. That's everything about parabolas. Let's talk about ellipses, or ellipses. Let's talk about ovals. Okay, so our standard form for ellipses is x minus h squared over a number squared plus y minus k squared over a different number squared. So instead of putting the same thing, I'll put a different symbol. And in our notes, we had a's and b's, and that's great, but what is important here for ellipses is that we're going to do the bigger number on bottom minus the smaller number anytime we want C to find our focus, okay? And so you can think about them as A and B, but in some ways I feel like that's confusing for when we get to hyperbolas. So what's underneath X is telling us how much we're going to the left and to the right. You have to square root it, but it's telling us how much to go left and right. The number under Y is telling us how much to go up and down. In order to find this time, we have 2 focuses, which we call foci, and we don't have a directrix at all. And so depending on which way is bigger, that's how we know what our focus is. And so we could have a wider ellipse, and so that means our focus is on our wider axis. That's called the major axis. Or if we have a taller ellipse, then our focus is on still the bigger axis. Okay, so it just depends on what your situation is. Now let's actually look at some problems like number 6. We have x squared over 25 plus y squared over 16 equals 1. The thing is, Graphing this should not be difficult. My we'll come back to vertices. The center of this ellipse is at 0, 0, because I don't have parentheses on top of my fraction, so it'd be like x minus 0 and y minus 0. In order to draw this, we need to know how much to go left and right and how much to go up and down, and that comes from these numbers on the bottom. I'm going to go left and right 5, because 25 is under x. I'm going to go up and down 4, because 4 is underneath y. I'm centered at 0, 0, so I just need to count this out. And then do my best to draw something elliptical versus, you know, squarish or whatever. That's close enough. So let's fill in the rest of this. And all that matters here is that I know what each of these words mean. For instance, our vertices are the endpoints of our major axis. So the wider direction, what are those endpoints? Well, one of them is negative 5, 0. One of them is positive 5, 0. So that would be positive and negative 5, 0 if you want to be lazy and write it in one point, or you could write out negative 5, 0, positive 5, 0. Our foci we get from that magical letter C that's going to come from the bottom of our fractions. For an ellipse, which has a plus sign here, we subtract our bottom numbers and then square root, and that gives us C. Okay, so there's a plus sign in the middle. We're going to do the opposite and subtract these to get 9, square root to get 3. C is 3. What that means is that from my center point, I need to go 3 to the right and 3 to the left, and that's where my foci are. My foci or foci, however you want to pronounce it, are along the major axis or along the longer axis. So I can write this as one point again if I do negative 3 and positive 3, so plus and minus 3, 0. That's my foci. Then these other two things, M sub j is for our major axis. We want how long the major axis is, which is 10, and how long the minor axis is, which would be up and down in this case, so that's 8. Again, it gets a little more complicated if we end up not having our center be at 0, 0, but still doable. So to draw this, we need our center point, which is the opposite of negative 3 and the opposite of negative 4, which is 3, 4. And we need to know how much we're going left and right and up and down. So left and right is under x, so that's 2. Up and down is under y, and so that's up and down square root of 9, which is 3. So we're going to go to 3, 4. We're going to go left and right 2, and up and down 3. Obviously your graph can be a little nicer because you've got grid lines and I don't, but that's the gist of it. So the center is 3, 4. Our vertices are the endpoints of the longer axis. So it's longer up and down. So what is the top and bottom point of this? Well, as long as you draw it using your grid lines, it should be easy. We can't write this as one point. One of our vertices is 3, 7, and the other one is 3, 1. Because it's the top here and the bottom here. We also need the foci. So because it's a plus in the middle, we're going to subtract our bottom numbers because we're going to do the opposite. So always do the bigger one minus the smaller one, otherwise we'll end up with imaginary numbers, which would be weird. Square root it, and we get C is 5. I mean square root of 5. We have to go from the center point, which is 3, 4, we have to go up and down square root of 5, which I don't know exactly, well, I do know what square root of 5 is. It's like 1.7 or something like that. No, it's not. I don't know what square root of 5 is. Never mind. It's bigger than something. Who cares? Okay, so from the center point, we're going to add square root of 5 to 4. We're going to subtract square root of 5 from 4 because that's the y value of our center point. Well, because it's a square root, we can't really add and subtract that. So we're going to write 4 plus and minus square root of 5 to show that we're adding square root of 5 and subtracting square root of 5. The way I know to do that to y is because our foci are along the major axis, which means we are changing y. We're going up and down to draw our foci. And then our major axis and minor axis lengths should be easy. The longer axis here is a length of 6. This shorter axis is a length of 4. Now let's do completing the square for an ellipse. Which, this is a little bit tricky because not everything is on the same side, and that might throw you off at first. When we complete the square, we want anything that has a squared term. If it has another term that's not squared, that's what we need to work with. So like 9x squared and 18x need to go together, and we're going to have to complete the square on those. And then our y's need to go together. 16y squared. I didn't mean to put an equal sign in the middle of that. Hang on, that should be a plus sign. My bad. Plus 16y squared, and we need to move the 64y over to the left side. So that'll be 16y squared minus 64y. We're going to complete the square on that. The 71 can stay on the right side because it is not involved in completing the square. Now, before I can actually work out what's in the blanks, I absolutely have to take out what's in front of x squared and y squared. If you don't, you'll do it wrong, I promise. I actually am a pretty good complete the squarer, and if you don't do it this way, you won't do it right. So take the 9 out of both of your x's, and then you have your blank still that we're going to fill in a second. Take your 16 out of both of your y's, and that gives us minus 4y, and it equals 71. Now, I'm ready to fill in my blanks. The reason we don't take out an x or a y that they have in common is because we want to get something inside of this parentheses that we can factor into x minus something squared or x plus something squared. And taking out an x doesn't help us do that. So I take the number in front of x, I half it, and I square it. So that's plus 1. Do the same thing with my y's. I half it and get negative 2, square it and get plus 4. Now, I have to account for what I just did on the other side of my equation. I just added 9, and I added 64, which means that on the right side, I need to add 9 and I need to add 64 in order to keep this balanced. So this 9 on the outside hangs out until after we factor here. X squared plus 2x plus 1 factors into x plus 1 times x plus 1, which is x plus 1 squared. Y squared minus 4y plus 4 factors into y minus 2 and y minus 2. I add these together and I get 144. And so if it's helpful, look back at a previous problem and look at what your goal is. Like look at number 7. The difference between what we have and number 7, or at least one of the differences, is on number 7. It equals 1. And so let's make this equal 1. To get rid of this 144 so that it's a 1 instead, I need to divide by 144. And when I do that, I'm going to simplify 9 over 144 and 16 over 144 and leave those numbers on the bottom. So this should be x plus 1 squared over 16 plus y minus 2 squared over 9 equals 1. That's my equation in standard form. Then I can fill in everything else as well as graphing this. So sure, let's do that. I'll graph it up here. The center is at -1, comma, +2. So that's up here. And then I'm going to go left and right 4 and up and down 3. And draw my ellipse. So my center is -1, comma, 2. My vertices are the endpoints of my longer axis, which is the left and the right side. And so that would be -5, comma, 2 and 3, comma, 2. My foci, I need to really quickly subtract my bottom numbers and then square root. The square root of 7 is what I would add and subtract to my center point to figure out what my foci are. And so because my major axis is going left to right, that means I need to add and subtract from my x value of my center point. -1 plus or minus square root of 7, comma, 2. Then I just have my major and minor axis. My longer axis has a length 8. My minor axis has a length of 6. Now the other thing we can do is they can give us some information and ask us to figure out the equation for an ellipse. And it may be helpful to go ahead and graph at some point, or just to kind of sketch what's going on. On number 9, we have our foci at positive and -2, comma, 0. We have our x-intercepts at positive and -4, comma, 0. So let's think about this graphically. Even though we're not given a graph, we can still think about what's happening. Our x-intercepts are positive and -4, which means that it goes through at -4 and +4. More importantly, in some ways, is what our foci is telling us, because our center is in the middle of our foci. So if our foci are at positive and -2, the center point has to be in the middle of that, so our center has to be at 0, 0, which means that I can go ahead and write this as x squared over something plus y squared over something. And because the center is at 0, 0, that's how I know that this is actually going to be my vertices, the endpoints of my major axis. And then I'm going to have to go up some unknown amount at the moment and down some unknown amount to finish my ellipse. So because I'm going left and right 4, that puts 16 on the bottom of x. And the thing is that 16 minus whatever's underneath y has to equal c squared. Because my foci are positive and -2, comma, 0, that's telling me what c is, because c is the distance of the foci from the center point. So I need to put 2 squared over here, which is 4. And then I solve this to figure out what b squared is. And if I do, I get 12. That's what goes on the bottom of this fraction. This is my equation. It asks us to go ahead and say what a, b, and c are. A is the bigger of the two, so that's 4. B is square root of 12, which simplifies to be 2 square roots of 3. And c is 2. And so on each of these other ones, it just depends on what they're telling me. And like I said, it really helps a lot of times to draw the picture that's happening so that you can actually wrap your head around what you're being told. The biggest thing to remember is your vertices are endpoints of your major and minor axis. So whichever way it tells you, if it tells you the vertices, it's those endpoints of either side. Your foci, though, tell you how far am I going from the center till I get to that magical point that would basically help me if I was on a computer trying to draw an ellipse. We would have to use that foci in our programming to draw the ellipse correctly or easily or something like that. Now, let's go to hyperbolas. Here's the difference with hyperbolas. We have two different kind of standard forms here. One of them has x first, and the other one is going to have y first. And we'll talk about what the difference between these is as soon as I'm done writing these down. So the first equation, where I have x first, means that the actual hyperbola part of this is going to be on the left and right side, because that's the x directions are left and right. When y is first, then our hyperbola is going to be up and down. The things that we need on hyperbolas are vertices, which come from what a is. So the bottom of the first number are telling us about our vertices in both cases. And then we also will have to talk about the foci. Now in this case, depending on which way that our hyperbola is, like we'll draw a box and our asymptotes and all of that jazz. This is kind of a terrible hyperbola. But what matters is our foci are on the inside, just like with our parabolas. Like our hyperbola is going around our foci. And so there's a minus sign in between these, and so we're going to do the opposite. We're going to do a squared plus b squared, and then square root it. And that's going to give us the c that we need to figure out what our foci are. Let's just jump in and try one. So on number 13, we have x minus 3 squared over 16 minus y squared over 25 equals 1. So we can know a lot of things just from this equation. We can know that the center of our hyperbola is at 3, 0, because we look at the top numbers to figure that out. We can know that we're going to go left and right 4, because that's what's underneath x. We know that we're going to go up and down 5, because that's what's under y. We know that this is going to be on the left and the right side of our box, because x is first in our equation. So let's draw this. Oh, that's terrible. Undo. Still bad. Okay. Much better. Okay, our center is at 3, 0. And our box that we're going to draw is left and right 4 and up and down 5. And so I'm going to make a box. Which is easier with grid lines in my opinion, but hey, I think I did pretty good. Our asymptotes go through the center and the corners of our box. So there's one asymptote, here's the other one. Our hyperbola is on the left and the right side of the box. It touches the box in the center on the left side, in the center on the right side, and then it goes out towards our asymptote, almost like a parabola does. It looks like a U-shaped graph out towards our asymptotes. It wouldn't cross our asymptotes, but you don't necessarily have to get super close to your asymptotes as you're drawing it. So because we have the picture, it's going to be easier to find what they asked us. We know the center is at 3, 0. The vertices are these points where my hyperbola is touching my box, which if I look is at -1, 0 and 7, 0. My foci, I don't know necessarily what they are at this moment, but I know that one of them is over here on the left, one of them is over here on the right, at points bigger than -1 and 7, like more to the left than -1, more to the right than 7. To figure out how much they are out, we are going to have to look at 16 and 25. There's a minus sign between these, so we're actually going to add 16 plus 25 and square root, which gives us the square root of 41. So from my center point, I have to subtract square root of 41 to get here. I have to add square root of 41 to get over here. And so those are decimals. And so we're just going to write 3 plus and minus the square root of 41, comma 0. Because we're not leaving this x-axis. We are just going left and right. So we have to add it to our x value. Instead of a major and a minor axis, we have a transverse axis and a conjugate axis. The transverse axis is the one between your vertices, and so that would be the horizontal direction in this case, and it has a width of 8. The conjugate axis is the other axis, so 10. So we're not even using the same words, so you wouldn't think of this as one of them being bigger and one of them being smaller. The transverse axis is the one between the two parts of the hyperbola that touch our box. The conjugate axis is the other direction. Finally, we have to label the equations for our asymptotes. What you need to remember, and this is something that you should really try to get in the long-term memory of your head instead of the short-term memory, is the point-slope formula for the equation of a line, which just requires us to know both a point and the slope, and then we'll be fine. So the slope of these two asymptotes that we have has to do with the rise over the run, as slope always does. We are rising 5 and running 4 for this positive slope. For the negative slope, we're going down 5 and right 4. And so what happens is our two slopes are positive and negative 5 over 4. And so if I want to make this easy on myself, if I pick the point that both of them go through, I can leave it written in this point-slope formula with plus and minus 5/4. So the point they have in common is the center point, so that'd be y minus 0, and then over here in my parentheses, it'd be x minus 3. And I can leave it like this. I don't have to solve this for y. If I did solve it for y, I'd need to probably, well, in this case, I wouldn't have to write two different equations. No, I would. Yeah, I'd have to write two different equations if I solved it for y, because we can't really solve for y when we've got positives and negatives. But I'm fine with you leaving it like that. You don't have to change it. Let's look at 14. If you feel like you've got a handle on this, you could skip forward to the next place you're having troubles, but since this does open the other direction, I thought it would be a good idea to go ahead with this. So drawing this shouldn't be too hard. Our center, now you do have to pay attention because our x value for our center is in the second equation, not the first. So it'd be -3 comma -2, not the other way around. And we'll have to square root to figure out, in this case, 6 is telling us how much to go up and down because it's under y. The 25 is telling us to go left and right 5. So if we draw this, I need to go left 3, down 2. Here's my center. Left and right 5. And up and down 6. And that's a pretty big box and kind of takes us to the edges of our graphs. Pretend that didn't happen up there. Draw your asymptotes. And then say, because y is first, that means that my hyperbola is up and down, just like y is. So up and down. Then fill in all the rest of the information. The vertices, where the hyperbola touches our box, is at -3 comma 4 and -3 comma -8. In general, if you have a graph provided and your graph is going off of it when you actually draw the picture, just do the best you can to make it look as reasonable as possible. It can be difficult to purposefully make problems that stay within an 8 by 8 situation. So just keep that in mind. Now, to find our foci, we're going to do 36 plus 25 and then square root it. 36 plus 25 is 61. So C for our foci is square root of 61. So from our center point, we have to go up and down square root of 61, which means that our foci are going to affect the y value for our center. So it'll be -3, comma, -2 plus and minus the square root of 61. Our transverse axis is the one that's on between our vertices, between our hyperbola, which is 12, and our conjugate axis is the other one, which is 10. Our asymptotes, again, we want to do this using point slope. We know that the slope here is up 6 and right 5 for our positive, down 6, right 5 for our negative. So that's positive and negative 6/5. And then we're going to pick our center point to use, which is going to let us write this as one equation instead of two. So I'm going to have x plus 3 and then y plus 2. That's my asymptotes. Now we might as well complete the square on a hyperbola just to practice. But hyperbolas and ellipses should be pretty similar when we're completing the square, really, and so would circles. Circles would be similar as well. Circles would be, in my opinion, the easiest thing to complete the square on, followed by ellipses and hyperbolas. Parabolas just, they tend to be be more complicated, or whatever. So we want to complete the square on our x's, complete the square on our y's, write this equation in standard form. And so that means that I need to take the 9 out of my x's, and I need to take the -1 out of my y's. You might be saying, well, why can't I just leave the negative there? It's not hurting anybody. But I cannot do completing the square if there's anything other than a plus sign in front of one of my squared variables. So that negative has got to go. If it helps you to write -1, you can, or you can just write negative. If I take a negative out of -6y, I get positive 6y. And it equals, I'm going to move the 18 over, so that's -18. So the next part shouldn't be that bad. Half and square -4 and get +4. Half and square 6 and get 9. But what we really did is we really added 36 and we really subtracted 9. And so on this side I need to add 36 as well as subtracting 9. And that right there is really important, because if you add 9, you get something that does not work out well. You subtract 9 like you're supposed to, it works out okay. So let's factor inside our parentheses. That'd be x minus 2 squared. This would be y plus 3 squared. -18 plus 36 is 18. 18 minus 9 is 9. And so again, glance back at the previous problem. What does standard form look like? It has a 1 over on the right side, and the negative is in the middle. If I had a negative in front of x squared instead of in front of y squared, I would need to flip these around so that y would go first instead of x. That's not the case here, so I don't have to worry about it. I just need to do some simplification. 9 over 9 is 1. This is just going to stay 9 on bottom. You don't have to write over 1 for this first fraction, but you can leave it that way if you want to. We have to graph this, which means we need the center, which is at 2, -3. So that's down here. We need how much it goes left and right and up and down. So it's going left and right, the square root of 1, which is 1. It's going up and down the square root of 9, which is 3. Draw your box. Draw your asymptotes. It's x first. X is our positive fraction, and so that means I'm going to draw on the left and the right side. And this shouldn't be any more difficult to find the rest of the information than the previous two problems. So I'll leave that to you to look at if you haven't already, to try to figure out the rest of that info. Now again, we've got some problems where they give us information and we're going to have to figure out what is going on. So what is going on? We're going to have to figure out the equation. So what matters here for vertices, because for ellipses, the vertices are along the major axis, but the major axis could be x or y. So we have to do more thinking as far as what number that's telling us about. But here, no matter what, this is telling me about A. And so that's helpful because it's automatically going to tell me what's underneath my first fraction. If it helps you to draw this out, then our vertices are here and here, which means that our hyperbola is going to open up and down. Our foci are here and here. And so from that information, like just drawing that, it should be really easy to tell the equation. Like our center's at 0, 0, and we're going up and down 2. The only other thing we need is how much we're going left and right to draw that box, and that's going to come from this relationship that we have between A and C. If you remember, because hyperbolas have minus signs in between, we have to do A squared plus B squared equals C squared. So that means we have 2 squared plus B squared equals 4 squared. And so we solve that and get 12. So A is 2, B is the square root of 12, or 2 square roots of 3, and C is 4. So since the center here is at 0, 0, which you can also tell without graphing just by saying, well, what's in the middle of 0, comma, plus and minus 2? It has to be 0, 0. Otherwise, we wouldn't have the plus or minus sign. We'd have 2 different numbers, and we'd have to use the midpoint formula. So because our vertices are affecting y, and because of the graph we have drawn, y is first. A is underneath our first fraction, so it's 2 squared, which is 4. Underneath x squared is b squared, which is 12, and it equals 1. Let's look at 17. Depending on what they tell us on these, it actually can be a little more tricky, but that's true with any of them. Like, we have to think about, what did you just tell me as far as these things go? Asymptotes. Okay, so my foci are affecting x, which means x has to go first. The midpoint of plus and minus square root, or plus and minus 10 comma 0 is 0, 0. So our center is at 0, 0. My x is going to go first, so I'm going to have x squared over something minus y squared over something equals 1. That's as much as we can get at the moment from just the foci, except that we know that c is 10 because our foci are 10 away from the center. Now think about what our asymptotes being at positive and negative 3/4 is telling us. It's telling us that we're rising 3 as we're running 4. The problem is that rising 3 and running 4 means that our box could be up and down 3 and left and right 4, but also we could rise 6 and run 8, or we could rise 9 and run 12, or any other set of multiples that would reduce to 3 over 4. So this is where we're going to have to think about a squared plus b squared equals c squared. If I use this right here, 3 and 4, since x is first, 4 would go first, although it really doesn't matter since we're adding a squared and b squared, which one you put first. 4 squared plus 3 squared, we want that to equal c squared. We already know that c is 10. So do this and see if it equals, which it doesn't, which means it's not 4 and 3. So go to your first multiple of 3 and 4, which is 6 and 8, and try those. So 6 squared plus 8 squared, or you can do it in the other order. Is that true? Is 6 squared plus 8 squared equal to 10 squared? Yes, it is. And so that means that a and b are 6 and 8. A is our left and right, so a is 8. B is our up and down, so b is 6. C we already said was 10. And so on the bottom here, you just have to remember it's a squared and b squared. So it's 64 and 36. We'll do 18 as well, because this is a little tricky. Or it's not that it's tricky, it's that it's different than what we've already been doing. So just to make sure that we can do it or know the thought process. Okay, so the first thing we need is our center point. And so because we don't have a plus and minus situation, we need to figure out what is the middle of either of these sets of points. What's in the middle of 4, 1 and 4, 9? Well, in the middle of 4 is still 4. In the middle of 1 and 9, we would add those numbers together and divide by 2. So 1 plus 9 is 10. 10 divided by 2 is 5. What we're doing is we're averaging the 2 points, and that tells me what is in the exact middle between them. So our center is at 4, 5. Our vertices tell us A. Our vertices are A away from the center. How far is it from 4, 5 to 4, 9? Or from 4, 5 to 4, 1? It's the same distance to both because 4, 5 is halfway. It's 4 between those. So A is 4. Also, I know that because my y is what's changing, and this is where it may help you to graph it. So I'm over here for all of these points they gave me. Over here at 4, I have a vertex at 1, and I have a vertex up here at 9. And so here's my hyperbola. So you can see halfway between is my center, 4, 5. This distance right here from the middle to my vertex is 4, so that's A. And so that also tells me that y is going to be first in my equation. If I didn't know it just from looking at the points, I could know it just by drawing a sketch. My foci, remember, tell us what C is. And so to do that, we have to say how far is it from each of my foci to my center point. So how far is it from 5 to 10, or from 5 to 0, which would be 5. So C is 5. Now we just need B. To find B, we do A squared plus B squared equals C squared, which you may know without actually having to do, because this does end up being a 3, 4, 5 Pythagorean triple, so B is 3. Now we can set up our equation. Y is first. We know what our center is. And then A is on the bottom of the first fraction, and B is on the bottom of the second fraction. And I think you should be able to do 19 okay. So 20 through 23 are circles, which are very similar to ellipses, except that we go the same direction each time. It should be really easy to do the circles. The center, you just pull out from the parentheses, just like we did with ellipses and hyperbolas. So the center is at 3, -2. The radius is the square root of the number on the right. So our radius is the square root of 25, which is 5. And so you just have to draw that Wow. Let's do that. Okay, so 1, 2, 3, 1, 2. Here's our center. Go 5 every direction. Draw yourself a circle. Clap yourself on the back. We'll do, trying to think if either of these, I mean, these are both pretty much the same as far as completing the square goes. Like I said, completing the square on circles should be the easiest of the completing the square situations because there should not be anything in front of x squared and y squared, so we shouldn't have to factor anything out. We also have to do less steps overall. So this is x squared plus 6x blank, and then y squared plus 2y, and then a blank, and it equals -6. So then we'll fill in the blanks with +9, and then +1. Put those on the other side as well. Factor. Add. There's our equation. We can get the center and the radius and be really cool people in graph. The final thing that we need to do is know how to tell the difference between a parabola, a circle, an ellipse, or a hyperbola. And typically the way that that happens is they'll give us something that we could complete the square on if we wanted to graph it. And that's one way of figuring out what type it is. But we don't actually have to go through all that trouble if we remember some key things about each type of graph. So it's kind of, in some ways, a process of elimination. Like, it's easiest to do it that way because some of these are a lot easier to spot than others. So a parabola has only one squared term. So either our x is squared or our y is squared, but not both. And so that would be number 29 on our review, which has x squared plus y plus 2x plus 1 equals 0. So since y doesn't have a squared at all, this has to be a parabola. The next easiest one to find is a hyperbola, in my opinion, because on hyperbolas we are subtracting x squared and y squared. And it could be that it's the other way around, that it's y squared minus x squared. But basically, one of those two coefficients should be negative. And so that happens in 30. I'm not going to write the whole thing down, but the important part is 5x squared minus 4y squared. Since that's a minus sign, this has to be a hyperbola, because if we complete the square, that will give us the minus sign between our fractions. The difference between a circle and an ellipse is that circles have the same coefficients meaning the numbers in front of our variables, the same coefficients for x squared and y squared. And so that is like number 27, which has 3x squared plus 3y squared. So since those are both 3's, it's a circle, because if we completed the square and we tried to make it an ellipse, well, it'd go the same distance left and right and up and down, which we call a circle, because it's basically like it has a radius of something. The ellipse, though, has different coefficients. So like 20, in front of x squared and y squared, like 28. So that would be 3x squared plus 2y squared. So because those are different in front of x squared and y squared, it's an ellipse.